Okay, I assume this is now visible and you are getting the correct screen. The sound is good. So hello, everyone. And thank you for attending this, I call it a webinar rather than an IPI talk. This has been long overdue. I meant to do this for a while, but I think is getting to a point where we have to get more clarity around scientific publishing and some specific things about IPI letters as well. So let me just go straight to the content slide. So what I'm going to cover in this short presentation is why, what, where, and how. These are the key things that I'm going to cover. Why do we need to publish? What can be published? Where you can publish, how to write an article, and a few things around what not to do and what to do. I'm going to say a few things about a patent or an article as well. This is very important. It might be a rare situation, but I think it's very important to be aware of this. So the first thing is why do we need to publish? And I can argue that progress can only be achieved if our research and our research results are promptly shared in the public domain. We get our scientific output shared and known to the wider community. And I can give you an example. Just imagine if maybe there are a few key discoveries in the world, and in the world of physics, particularly, that changed the entirely our society. And you can trace all discoveries are important, but some of them are really incredibly powerful. One of them is the discovery of electricity. So just imagine if Faraday, when he discovered essentially the Faraday effect and electricity, would have not shared his results with the wider community, would not tell everyone how to do it, or maybe Newton when he discovered I don't know, the law of gravity or things like that. What if they would have kept this in a drawer in their office and not share it to anyone? Essentially, they could bring the entire planet decades, if not centuries, backwards. Sort of, they will stagnate the entire progress of the planet. So the publishing scientific results is a public duty. It's not something that you have to do because somebody said so. It's something very important to always publish any kind of results you have. It's a duty, as I said, to let others know about your research because it can help them advance their own research. It can help others develop new ideas, new things. Even small incremental steps in any research field, any research topic, are very powerful. So you have to share your research all the time. How do you do this? There are a few options you have to actually get your stuff in the public domain. One of them is obviously going to a conference. You can do public lectures, which are not like formal conferences. Here in Portsmouth, there are a bunch of academics. They do something called a pint of science. Essentially, they go to local pubs Friday evenings or Saturday evenings, and they do science lectures in the pub, free of charge. People have a pint of beer, and they put a projector up, and they do outreach, science presentations, and all that with questions and debates at the end. Very nice, very powerful. Public lectures, presentations in the conference presentations. You can use. There are so many choices now to use modern media channels. From I have in mind YouTube, blogs, maybe I don't know, Instagram, all sorts of media channels, Facebook, and so on. You can write a book, but by far the most powerful way of communicating any scientific results is probably still publishing a scientific journal paper, okay? Because it has some kind of traction and weight to it than all the other methods of communicating. And one of the traction is the peer review aspect, okay? Which is not something that should be taken too too radically. I'll get to that in a minute, but it's a powerful method of communicating your scientific results. Why would you need to publish? You need to publish because it's a good way of recording your work and ideas for possible future use. And what did I mean by this? I meant, let's say you are developing, for example, when Einstein developed special relativity and general relativity, there were no methods of testing experimentally his results, especially in the general relativity. It took about 10 years, I believe, when they first had the solar eclipse, and they could see the bending of light around the curvature of the space time around the sun, and he matched the predictions of the GR, okay, Einstein's GR, and that was one of the confirmations, and a few others followed. But what I'm trying to say is that if you have some kind of work that is done, but is highly theoretical, or maybe some kind of concept, some kind of new device or new application, but technologically it cannot be confirmed today, or it cannot be implemented or designed or built, you still need to publish that, because it might be possible in the near future to the technological advances to become to make it accessible, sort of like in terms of experimentation through the various technological advances. I mean, we're making so much progress in computing technologies, in solid state physics, nanotechnologies, nano fabrication, nano manipulation, nano everything. And things that are not possible today, they might be possible tomorrow. So you have to get your record done and put it in the public domain. Maybe in the future it will be possible to test it. And it goes to some of my works, actually. I have some papers that are still not experimentally verified, that they're waiting experimental verification. And I know some of you guys, if you are here in this lecture, there are some of my colleagues at IPI thinking actively of designing, I think Jeff is doing this and a few others, designing experimental protocols to test some of the theoretical concepts that I proposed. So publishing is another very good way of acquiring a track record of your research work. And by this, I mean getting a good CV, especially if you need the publications in your CV. I have in mind, like somebody chasing some kind of academic career, or even if you go into industrial research or this kind of stuff, having publications, it does improve the look of your CV. So it's a good track record. A good publication record is not only good for you, but is good for the organization you work for. It brings respect and recognition and all that to the institution. If you are not affiliated, it helps IPI. I suppose if you are using IPI affiliation, it helps IPI. But also it helps you in other ways. It helps you get research grants, again, jobs, raising your personal profile. And when I said research grants and jobs, is really no other way of judging someone's quality, academic quality, but looking at the quantity and the quality of the publications. You measure that through the citations and the number of publications and the quality of the journals and all that. So there is no other way. The research grants, yes, they look at the proposals, but actually I do review grants all the time, and all of them are really high quality. All of them are good proposals. It comes down to the credibility of the investigators, whether they can deliver the proposal or not. And you look at their profile and all that, and you judge whether it's worth allocating the funding. The last one here, he says it helps finding collaborators, and this is more or less what we do at the IPI through the Google group exchanges, and I know it led to some collaborations. I certainly have been exchanging things with a few of you, not as much as I wish, but I'll give you an example. In my own case, I published an article in 2010 or 2011, and it was a theoretical study on ferroelectric materials, a new model, and it got picked up by a group of researchers in China. and they were doing experimental work on the same kind of systems, and it appeared that my model would fit their experimental data. So they emailed me if I want to look at their data. They didn't quite understand how to go about, the theoretical aspects, how to test their data. So they wanted me to collaborate, and we ended up publishing 2 or 3 papers together. What is interesting, I said it helps finding collaborators. What is interesting, I never met these people. In fact, I still don't know if I was dealing with a man or a woman. We just exchanged emails and worked on this research collaboration, but we never met. This is just down to an article I published, and they contacted me and so on. So it's really powerful. Publish all the time. Publish your research because it's very important from all angles. Okay, so that was why. Now is the what. What can you publish? So you can publish essentially any scientific result that shows something that hasn't been observed before. That's quite rare, actually. When you find something unique or first in the world to do it or things like that. That's not always the case. Most of the research publications are small incremental steps within a given field of research. They are not groundbreaking research discoveries or something like that. They are little incremental steps. But any of those little incremental steps you develop is publishable. Any scientific results that would contradict some previous reports. So, for example, I said the information has mass, and somebody has an experimental protocol that proves the otherwise. It says it doesn't, it didn't. Okay, that is publishable. Okay, because it contradicts a previous report or a theory or something. Any scientific results that improve some previously reported data. I used to work for National Physical Laboratory in West London about 7 years. I was a research scientist. This is like Max Planck in Germany. This is like NIST in the United States. It's the Standard and Measurements Institute in the UK. And people over there, they are still publishing papers by adding another digit of precision to the mass of the electron, or the measuring the using atomic clocks to measure to do the etalon for a second with the, I don't know, precision of 10 to the power 20 or whatever. These are not discoveries or studies that are really nothing new there. They just improve on previous results a little bit, another brick in the wall, another small improvement, but that is publishable. That's what you need to understand, is publishable. You can publish any experimental study, any new concept, any new theoretical model, any possible application. And I need to emphasize, even if the application is not practically proven today. So let's say somebody has an idea about a new propulsion system that uses, I don't know, some completely novel technology. Is not a turbojet, is not some jet plasma, is not some, God knows what propulsion systems are there, but he's using some kind of, I don't know, some different type of propulsion system, okay? And yet that idea, it looks feasible today, but there are no technological tools available to us to actually implement it. You have to publish it, because in 10 years' time, maybe those problems are being solved, and maybe your idea will be picked up again. You have to publish it, even if it's not practically. But when you present something, however cuckooland it sounds, or science fiction, it needs to be backed by some kind of scientific evidence, some kind of diagrams, some kind of simulations, some kind of theoretical estimation. Even though you don't build it, you don't prove it, but you need to back it by something. So this is the kind of, essentially anything is publishable as long as there is some kind of incremental development there or progress. You discovered another way of measuring something, another type of metrology, another method or instrument, or an improvement to an existing instrument, a new material, some new properties, some new phenomena, new effects, this kind of stuff. It's all publishable. If you look at my record, I worked quite a lot on the multicaloric effect. This is essentially, I published the theory of this multicaloric effect. is doing very well. There are citations into the experimental side of this effect and the theoretical side. Anything that is any new effect, new properties, new heavy, publish it immediately. So when I say publish, what choices do you have? As I said, you can do a book, you can do a review article, you can do a paper article, you can do a letter article, you can do a rapid communication, news and views, and so on and so on. Each of these choices depends on what you are communicating. What is the work you are doing? What is the nature of your research, and what is the targeted audience, and so on and so on. So, for example, if you have a research discovery or some kind of research paper that you finished or some kind of research work, I would not go for a book. Obviously, you go for a rapid communication, a letter article or a paper article. If you have a portfolio of maybe 10, 15 articles in a given research field, then you can consider a review article or a book even. But you need to have credibility. You need to have a track record in that given field. You need to be quite known. You need to have minimum 10 articles, let's say, published in that field, and then you can go and compose a review article or a book where you add all your work in it, but you also add what others did in addition to your work, and to do a review of all that field in a nice review article or a book, and you cite all the other works and you put them into a nice coherent story. That is something to do when you work a good number of years in a given field, and then you are ready to put together, to condense everything into a book or a review article. To give you an idea, I have over 100 articles. I only wrote 2 review articles, okay, and one book, a small book, and 2 review articles. But in honesty, I have materials for another 1 or 2 review articles. I just didn't get a chance to sit down and do it, because is more value in a research article than a review article. At least in my books, is more value to get research out rather than reviews out. Reviews are very good to boost citations. All right, remember this: you get a lot of citations from reviews. But okay, so this is closing the chapter of what you can publish, and this it's one pager here about the choice between a patent or an article, and this is something very, very important. If you are in this situation, it's a difficult decision, but what it means that you have done something so powerful that it has not just scientific potential but also commercial potential. It can be patented, maybe, so you need IP protection, and you can make money. Okay, so you have an idea, like a new concept, a new application, a new method, a new something, a new material, a new phenomenon, a new something, and that could, let's give you an example. You find room temperature superconductors. Hallelujah. You do that, you need to be insane to publish first before you do a patent. You first do a patent and then you publish after. Okay? In other words, you make your millions, if not billions, and there are so many discoveries waiting, like massive developments that are waiting to be, to be uncovered. You make the mega money, and then you get the Nobel Prize as well. But here is the problem: if you let me get all the lines. So if you have some kind of novel contribution that has commercial potential, and you make any form of disclosure of that, any form of disclosure, not necessarily an article. If you publish a blog or an article, or you go to a conference or anything, even if you speak to somebody without using a non-disclosure agreement, that is no longer IP protected or patentable. You can never apply for a patent the moment you disclosed without NDA your invention or your idea or your whatever you did. So when you are in this situation, you don't rush to publish. What you need to do, you need to assess the novelty of your invention, assess the potential for income, And because the patents are not cheap, when you do a patent, you need to spend some money, and it costs money to maintain it as well. So you need to assess all these, and if you think you can make money, if you think there is mileage in that, then the correct procedure is to actually submit first a patent. You file a patent, and then you can publish the paper immediately after that. The moment you publish, maybe you don't know this, but there will be some people here from industry. I mean, I think Peter he has a lot of IP, for example, and many Barry did IP, and many of you. I only have one patent, but there will be many here that did intellectual property. But the moment you submit something, the moment you file the patent, you are protected already, and you can disclose it in the public domain. You can write articles, you can go on television and speak about it. You are protected the moment you file. But if you go public before you file, it's game over. Bye-bye. You missed the opportunity. So you guys remember, whatever you do there, if you have this beautiful situation where you crack something that is important scientifically but also commercially valuable, do consider a patent first, and then go for the article. Okay, so that's an important thing. Where to publish? Now we are at the where. And I'm getting to the strategies and things in a minute. Just be patient with me. I'm going to cover all the things. So where to publish? The open access journals. Okay, you all know what it means. It means the author pays a small is not quite small. If you go to Nature, it's £5,000, not dollars, pounds. Nature Communications, for example, is £5,000 an article. I publish a lot in AIP Advances. That's about $1,200, so it's about £1,000. The APC, article publication fee or charge. The idea is that the author publishes, pays a fee, or the organization pays a fee, but the article becomes freely available to anybody on the planet to download, to read, to cite, to access it, or whatever. The other publication model is you go to a traditional journal that you pay nothing to publish, but in order to get your paper in the hands of someone, that someone has to be a paid subscriber to the journal, or his institution or her institution has to be subscribed to the journal and pay a subscription fee. And guess what? We have 1 billion plus Chinese, 1 billion plus Indians, 1 billion, I don't know how many billions in Africa and other countries. Not everywhere is possible to get these subscriptions paid. They are not cheap. Okay, so institutions or individuals will not, certainly individuals will not pay subscriptions. So what it means you restrict your market access to your articles to a narrow elite class where they have access to the papers through their institutions and subscriptions. But if you do the other alternative, where you go open access and pay the fee, then your paper has instantaneous impact on the planet. Okay, so that means more citations, more uptake, more readership, more everything. Okay, so that's one choice. That why I became really obsessed with open access. I teach at the university one module on multiferroic materials and applications, and I wrote 350-page lecture notes on this module. And at some point, I wanted to write a book. And all my articles, I have dozens and dozens of articles published in this area of physics. They are published in regular journals, not open access. And I realized that in order to use my own images, my own text, my own articles that I wrote and published, I need permission from the journals. And in most of the cases, I had to pay them money to use my own images. Because when you publish with these journals, you have to sign off the copyright to them. If you publish open access, you retain the copyright. It stays with the author. So after you publish in some open access journal, you can take the same article and put it wherever you want, share it wherever you want, put it into a book, copy and paste it as it is. You can do whatever you want. It's yours. You keep the copyright. Well, I couldn't do that with my lecture notes, which I wrote, and all the work I did and all that. I signed off the copyright. I still didn't do that bloody book. So since then, I decided to go and try to chase open access rather than regular journals, so I can do a book. And this is why I did a book recently, because I could just put all my articles together into a book, and it was just a little bit of adding a bit of text, an introduction, a few more comments, a few more things, polishing a little bit, but essentially I copied and pasted my papers into a book. Essentially, they were open access. So where to publish? There are journals just like cars. You go on the street and you see a Bentley, you see an Audi, you see a Ford Focus, you see a Volkswagen something, you see an I don't know, an Opel or something. The cars are cars. Okay, so there will be cars that cost $500,000, luxury cars, cars that are $10,000, and so on. The same is with the journals. Okay, you have what we call the high impact factor journals, okay, or the prestige journals. These would be the Austin Martins, the Bentleys, and the Mercedes, and all that, okay, of the equivalent in the car industry. And then you have journals that are not these elite, elite journals. They have a lower impact factor, and how do you choose, and what is the strategy? Well, my philosophy is the following. Whether you drive a Austin Martin or whether you drive a Ford Focus, they are both cars, and they both take you from A to B. There is no difference between it's almost similar comfort. It's not, maybe you don't have the same gizmos and the same things, but they are both cars, and they both take you from A to B with a legal speed limit on the roads and so on. So to me, there is no difference between one and the other. And to be honest, there were Nobel Prize discoveries awarded to for articles published in impact factor journals of impact factor 1. So one example that comes from my mind, to give you an example, the Nature and Science, they have impact factors of 40 or 50. Some of them, I think, there are even touching on 100. These huge impact factors. Impact factor 1, Japanese Journal of Applied Physics. Impact factor 1, the guys that won the Nobel Prize for the discovery of the blue LED, okay, the two Japanese, they published all their papers in Japanese Journal of Applied Physics. Never in Nature, never in PhysRev, never in Science or anything like this, never. A modest journal, impact factor 1. And guess what? It made no difference. If the citations are there, if the quality is there, it's a journal, happy days. They won a Nobel Prize, okay, eventually. So just like I said, whether it's a Ford or I don't know, a Jaguar or something, it takes you from A to B. It's a car. They are all cars, okay? But what is the strategy? Once you write a paper, you judge the quality of your paper, and my advice is to actually try the highest profile journal suitable for your article. The highest impact factor suitable for your article based on the quality of your work. And why is that? Is because it costs you nothing. Okay, if you try, you don't kill anybody. You try, maybe it goes through the editorial screening, maybe it goes through peer review, maybe you get it published. But if you don't get it published, one word on this. When you go to high impact factor journals, you need to remember one thing. You need to consider the time it takes to peer review and to get a decision and to get the paper published. During this time, your work is exposed in the public domain to potential peer reviewers, to other scientists, to editors, and so on and so on. If you do something really, really cracking, something really important, do you really want your work to be for 1 year plus in the public domain without any credential to you, without any recognition to you? There is no stamp associated to you. There is nothing. They can reject your paper, and then your idea appears rebranded slightly differently into another journal and published somewhere, and you have no say on that, no nothing. Okay, you can't prove anything. You can't. So my strategy, and this is my advice, is my way, I'm not telling you to do this, is my strategy is to do that Japanese Journal of Applied Physics, what those people did or whatever, is to get the paper published as soon as possible, get it into the public domain, into a journal that has indexing, cross-reference, DOI number, all these things, okay? It's preferable if the journal has an impact factor. For example, IPI letters has not got an impact factor at the moment. It takes a few years to get an impact factor, and you need to go through an application process and all that. So we are not quite there yet. But if you can go to a journal that has, however small impact factor, and is open access, and it has a fast publication rate, I think that would be my prime choice. Okay, so this is I'm giving you the most honest views and strategies that I deploy myself. If you get rejected, attention, this is very important. If you get rejected and they don't give you the resubmission option, they don't say, hey, is rejected, but if you do this and this and this and this, we can reconsider the paper. It just rejects the paper, and they say no resubmission. There is no option to resubmit. Okay, then what you need to do, you need to address the feedback and whatever the reviewers said, and if you have any feedback, address all the comments and everything, and go to another journal. I put in red here, and I can't emphasize this clearer than this. Never leave a piece of work unpublished. Never leave a piece of work unpublished. If it gets rejected, it's a human process. It is very subjective, the peer review and all this. It means nothing. Maybe it needs a bit more polishing. Maybe you need to do a bit of extra work on the paper, but never leave a piece of research unpublished. Okay, so what options you have if you get rejected? You can go to a conference, and many conferences, they do conference proceedings. The conference proceedings are full publications. You get DOI number, they go into a book, and it's like a full publication. But guess what? You get your name attached to your idea and your work, so it stays with you. It doesn't go into the vacuum. It doesn't get lost. You can go to some of those preprints, especially the preprints repositories where they give you a DOI number. Those are very powerful because you have something that is citable. Once you have a DOI number, you can cite it. Okay. And if these are not good for you, or I don't know, not choices or accessible to you, you can even go to a blog. You can go to some social media or something, and you need to remember the copyright. Anything you write and anything you do, you retain the copyright by law. The only thing you need to do to retain the copyright is to put a date and your name on anything you create, whether you draw a diagram, whether you write a paper, whether you write a blog or something, whether you write another equation or a poem or a song or anything creative, anything you do scientific, anything you do, if you put a date on that document or digital asset, and you put a date and a name, that becomes copyrighted to you by law. Okay, so that's what you want. You want to have some kind of stamp with your name on whatever you do. The best is to publish. Never leave something unpublished. All right, I'm going to go to the next slide now. This is it's quite funny. It says it says, why does it say free meets? No, it's meant to be the meet about peer review, not free meets. Sorry about the typo there. The peer review process, you need to understand the peer review process is a bit of a joke, okay? And it's something that I call it, the peer review is almost like a lottery sometimes. And I base this on the proof of this is that most of the Nobel Prize discoveries and papers have been first rejected at the initial submission, okay? At the peer review process or even by editors, okay? This is an article published by Juan Miguel. It's published in 2009. He Scientometrics journal, okay? So this guy took the time to categorize and research all the Nobel class discoveries that have been submitted to a journal and they got rejected. Okay, Nobel Prize discovery, and it's dozens and dozens and dozens. It's unbelievable. In fact, in the UK, not only I know a case where a discovery was rejected at the initial submission, but the same professor many years later, he wrote a grant for funding to one of the UK funding agencies. And the same day he got rejected at his grant, he won the Nobel Prize. He was notified that he won the Nobel Prize exactly the same day when he got the rejection from, I'm not saying the funding agency, because we need to be careful with this online content now in UK. People get arrested for what they say online and things like that is becoming quite mental. So I'm not naming anything. I'm keeping it open, open and broad. But how crazy is that? Just imagine. Now, if you want, I'm going to put this on YouTube. If you want the link to this article, here is the link. And there is another beautiful link on a blog about, actually it is free, mates. It is free. Okay, there are probably, I don't know what are the other two. I know one is the subjective aspects of peer review and how ridiculous is the whole process, because you get, it's not working. When you have Nobel Prize discoveries being rejected, we know the system is not working, okay? So, and we agree on this, and it's been documented scientifically now. And on the same thematic, I'm going to give you an example now. This is quite funny. Albert Einstein published over 300 articles between 1901 and 1955. And this Daniel, historian, science and physicist and the science historian, he documented the fact that Einstein had only one paper rejected, submitted to peer review and rejected, actually. It was a paper that he co-authored with Nathan Rosen on the gravitational waves problem. They published many papers together, actually. And this was submitted to PhysRev in 1936, okay? It turns out the PhysRev journal, around the same time, 1936, 1935, introduced the peer review process. It was recently introduced. Why I'm telling you this is because the peer review is something that was not very common. The peer review didn't exist. How in the past the journals, science journals would operate, they would have an editorial board. Somebody would send an article to the journal. The editors will sit down, one of them or a pair of them or a few of them, read the article and make a judgment or a decision on the paper to publish or not to publish, or maybe do some changes to it or some recommendations. But it was the editors. There was no peer review. So what happened? I think two things happened. Many more people started to submit research work, and it became unsustainable for editors to peer review everything. They also got to be lazy, maybe, and they said, okay, we can outsource the peer review. We don't need to do it. We send it to experts in the field, to do this for us and write a recommendation. In any case, the peer review process was not there since the beginning of time. It's a quite modern thing. Around 1940s was introduced, and it's very subjective. It's very imperfect. On the Einstein thing, this is the letter, or original letter that Einstein sent back to PhysRev when he was so really upset about the rejection, and he was quite crossed about the fact that they sent it to peer review to somebody. So I managed to find an AI that reads English text with an accent. You just say, I want French accent or German. So let me see if it works. I'm going to click this and read this letter with a German accent, just like Einstein would do. I certainly can't do German accent, so I'm just going to click.
Dear sir, we, Mr. Rosen and I, had sent you our manuscript for publication and had not authorized you to show it to specialists before it is printed. I see no reason to address the, in any case, erroneous comments of your anonymous expert. On the basis of this incident, I prefer to publish the paper elsewhere. Respectfully, Albert Einstein. P.S. Mr. Rosen, who has left for the Soviet Union, has authorized me to represent him in this matter.
So this is Einstein's response to, if I may ask, there is somebody with a microphone turned on and I can hear a dog barking. So if you could please mute your microphone. There's a microphone still left on. So this is his response to PhysRev, because he was so upset about the whole thing. It was so unusual to go to peer review. What do you mean peer review? You either publish it or you don't publish it. I don't need your so-called expert opinion, but quite the funny thing. This letter is from that article I told you about on the previous page. So let me go to the next thing. This is what I'm talking about here is steps and I think I have some kind of 9 steps to write an article. So let's go through this quickly. So let's say you do some piece of research and you finish some research. It could be some simulations, it could be a new theory, it could be some measurements, it could be some new designs, some new applications. The moment you finish, start writing up. That's what you do. Step 1, start writing up. So the first thing you need to do is to have, how do you start writing up? You need to have a clear story in mind. You need to know exactly what you want to report and what is the spin you put on your story. Okay. The message you try to put out there in the public domain must be super clear. Do not mix up messages or concepts or other things. For example, if you report a newly discovered experimental technique and you had the chance to test it and see the results, you should focus on, at least this is what I would do, you should focus on reporting the experiment and the new method, or you should focus on reporting the results. But I would not do the two together. I would not, and this is highly interconnected stuff. It's one method and the results produced by that method, they're highly interconnected. They make sense to go into an article, but even in this situation, I would not mix them up. I would just report in an article. Here is a new method to measure the speed of light using lasers and this technique and lock-in detection and all that, and I don't know, mirrors and all. You explain the technique, you show the diagrams, you detail everything that somebody can build the instrument, but you don't show any results or any like detailed results. You can show a quick test or something, a proof of concept or something. And then you don't mix, what I'm trying to say, you don't mix different concepts, different topics, different things, too many things into one article. You need to keep it simple and focused on one problem, okay? The best in this example I gave you is to publish 2 articles. One is the instrumentation metrology paper, another one detailing the results and briefly mentioning the paper, citing the original article and so on. Point 3, the moment you have a story in mind, the moment you have some results, then you have a story, a spin that you want to put in mind, you need to draw up like a structure of the paper, okay? The sections of the paper, the structure, things like title, abstract, introduction, experimental methods, I don't know, theoretical aspects, I don't know, derivations, whatever, your conclusions and so on. You need to draw up the structure of the paper. So the next step is step number 4. This is the most boring and the most, I would call it disgusting, but highly important, is when you sit down and start searching, doing your homework and searching all the literature available. You use Google, you use libraries, you use everything you can to look at all the literature available on that topic, on the research you did, what is out there related to that. It has multiple reasons you need to do this. One is to make sure that you cite all the relevant previous works to your paper. It's highly unprofessional not to cite relevant or previous works, especially if you refer to them or use their results. You need to make sure you don't reinvent the wheel. Maybe what you think you did new or what you think you discovered, maybe it's already done. So if that's the case, my advice is still publish it. But what you need to do, you need to try to change the spin of the story. You need to try to change something. You need to highlight other aspects that maybe they were not published, okay? Make some improvements, highlight the novel aspects. You still never leave something unpublished, never, okay? But you can't republish something that is already there. You need to change the spin a little bit. Doing the literature review, it helps you crystallize your ideas and the physics behind your work, because by reading what others did and everything, it potentially brings improvements to your own work. But this process is time consuming, is quite boring, and not always pleasant, because you might discover that what you did is not maybe as good as you think, or maybe somebody did it before, or it's not, it has to be done. Point number 5. Once you did the literature review, once you have a story in mind, once you have a structure in mind, you start writing what I call a master document. Hey, by the way, this is the method I do. It's not how it should be done. I'm not telling you this is the recipe how to do it. I'm just telling you from my own experience how I do it, and then along these lines, maybe you find something that resonates with you, something that you like it, and you adopt it, or maybe you adopt the whole strategy. But this is how I do it. I'm not saying it's the way to do it. I'm just saying this is how I do it, and it kind of worked for me. What I do, I sit down and write what I call a master document. This master document contains everything. You don't need to think much about the semantics, the quality, the aesthetics, the nothing. You just write, make sure you capture everything you've done in there into a master document. Everything related to that research, everything that came through your mind, ideas, impacts, things, everything that it needs to be in this master document, including literature review and everything else. Okay? Once you have this master document where you put all the images, all the results, tables, everything you have, equations, everything you have. Once you have this ready, then you sit down, take a break, a day or two, then you sit down, read it again, and judge, do a self-judgment, or maybe you can share it with somebody and say, hey, what do you think about this? All right? And judge the quality of this paper. This helps you find a suitable journal. Okay, it goes back to what I told you, the Bentley and the Ford and all that. Is it tells you maybe try this journal, or maybe try this journal, or maybe so important and you want that out in the public domain so soon that you go to the quickest publication possible, like maybe a preprint or something. I mean, I think they awarded $1 million for a preprint in the archives to one of the Millennium Problems. And I think the guy refused it. This Russian crazy guy refused the money. But the preprints are not too bad. Okay, I know it's not a journal, but they are not too bad. You need to get your name and your work out in the public domain ASAP. That's the idea. So after you find a suitable journal and you have a master document, then you go back to square one. You need to start working again on the document. Why? Because every journal, once you decided to go for a journal, let's say you go to IPI letters, you can't just submit anything there. For example, the referencing format is a specific format. You don't get published if you have the wrong references, like Harvard or something like that. Journals have specific rules. For example, PhysRev letters is 4 pages only, and a fixed number of words. Each equation, each figure, each everything has a number of associated words that they put on it. You need to calculate all the words, add all the words, all the equations, all the figures, tables and stuff, and make sure you are within the journal's limits for an article. If you are not, it gets rejected. So once you have this master document that I mentioned, you decide what journal you go for, and then you start formatting your article to the specifications of the journal. Use their templates, look at their requirements in terms of the length, in terms of images. They want vector format, they want this and that. They are very specific. Journals can be very, very specific, and they reject your work if it's not compliant. This is very boring. It's like rewriting the article once again. Very boring process. Step number 8. Once you finish this, you are ready to submit. Do not submit the paper before you check the editorial board of a given journal. Let's say you want to go to Journal of Applied Physics or Applied Physics Letters, or I don't know, one of the journals, okay? AIP, IOP, whatever. You need to go to the editorial board in the public domain of the journal there and check who is there and look at the kind of research they do. And if you are lucky to do some kind of research that relates to any of the editors, make sure you bloody cite some of their works. You cite some of their papers in your article. The editors, I mean. Okay? This is part of the political aspects of publishing and all that, because it's a process with people, for people, run by people, and so on. And it's not a perfect process. It's quite subjective. It's not. I just described. It's quite imperfect, and all these political aspects are quite important. So you need to make sure you play the political game as well. Some journals would require step 9 before you submit. They would require to list some potential referees or reviewers. Okay, it's very annoying when this is happening. And I know why it's happening, because I'm doing these IPI letters and I find it really difficult to find peer reviewers. The papers are being delayed and it takes forever to get a paper for the peer review and have somebody commenting on the paper, and I can't do them. I can't do them on my own. I need peer review, and they don't want a peer review. You contact even friends, you contact colleagues, they just don't have time. They say I'm not familiar with the field, I don't understand the paper, I don't have time, or they just don't respond. So journals, because of that, journals would ask you to nominate some peer reviewers. When you do that, you need to make sure you nominate somebody that is familiar with your work, somebody that did research linked to your work. But most importantly, if you nominate somebody, make sure you you cite some of their work in your paper, because if the paper really goes to that reviewer that you nominated, and you did some research that is related to his or her research, but you fail to cite any of their research, it's going to upset them. And this leads to rejection in many situations. Okay, you really remember this, very important, these political aspects. Okay, sections of an article. So we have quickly some more details now, more specific details. The title, guys, the title is I call this, the title and the abstract, the shop window of your article. Is the stuff that most of the people will see and read only when they come across your article in searches or whatever. The title should be clear, simple, quite catchy, relevant to your work. Don't make it too long, don't make it too short. Okay, but there are some clear rules for the titles. Do not use abbreviations. Okay, acronyms, abbreviations, all sorts of things. Do not use ground claims. Do not say like the grand discovery of the theory of everything and things like that. You do not use this kind of grand overstated titles, okay, or overrated. Title is very important. Affiliation, you need to list all the authors and co-authors on the paper. And if you don't have an affiliation but you are an IPI member, this was open to IPI research members, but actually I allow all members to use this affiliation. I told everyone in the past to use IPI, your town, your city, your country. But as you know, I applied for research organization registry, and now IPI is on this registry, is registered there, but they want this address. They want the address where the main website and the main organization is registered. So from now on, I think we are going to change to this affiliation. If you publish under IPI, is going to be IPI Gosport, Hampshire, UK is where I am now, actually, instead of Philippines, US, whatever, IPI. This is something to do with the research organization registry. The keywords, these are, again, very important for internet searches, for metadata, all these things that the journal would do. They need to be carefully selected, because they are the signals to your paper, if you want. They are the triggers to your paper in searches and everything, in bots and all these robots and stuff. The abstract and title are the most important. These are the bits that most likely people will read before they decide if they go on and read the whole article or not. So the abstract has to be captivating enough, the title in the abstract, to tell the reader, to convince the reader that this is actually an interesting article, and say to himself or herself, I really want to go and see what else they did. I want to see the details of this. This sounds like an interesting piece of work. So they go on and read the rest of the article. That's the difficult aspect of abstract. It's very nasty piece of text. It's a short couple of paragraphs that have to condense everything you did in your paper, the key results and everything, be captivating enough to send the reader to read the whole article, and it's very tricky to do this. Okay, abstract, a good title and a good abstract make more than the rest of the article. Next, the introduction. I already said about literature review and all that homework you need to do at very early stages when you start writing. Okay, but in the introduction, typically you need to explain what is the problem, what are you trying to solve, what your work brings new, what is the proposed solution, what did you do, and then in the introduction you need to blend in this discussion the literature review, highlighting the previous works, what other people did in this field or in this topic, and this is the most important. This is where you put most of your references. Most of the references in an article, they go in the introduction section. This is where you cite relevant works and everything. This is the bulk of references. 80-90% will go here typically. Okay, and this is where you have to cite the relevant people as well, the editors, the peer reviewers, potential peer reviewers, and so on. You miss somebody that has done work in this field that you are publishing, and you miss citing them, they will be really cross. If they read your paper, they will reject you. Okay. Other questions for the introduction, I mean, how the previous published work relates to this paper, what is the relationship, what you are doing new, what are the gaps in science, what you're trying to solve. At the end of the introduction, you need to make some kind of a brief mention of what you achieved and make a transition to the description of the work that you did. A nice smooth transition, and then you go into the sections. The main text, this is where you put everything about your work. The experimental designs, the procedures, the theory, the models you developed, software description, everything you did, it needs to go in here in great detail and make it as clear as possible. The conclusions, essentially, to remember what you put in the conclusions, your conclusions are a repeat of the abstract, except it's an extended abstract. Conclusions, you should see conclusions as an extended abstract. This is where you repeat what you said in the conclusion in different words, and you expand a little bit more and try to add things that you couldn't add in the abstract because of the limitations of text limitations and other things. Okay, so conclusions very important as well. Very important to to throw in the last detail or last things. Like in some of my recent papers, in the conclusions, I put some of the most controversial things in there. Like the last thing. And what else? Acknowledgements. This is a section that is ignored in many situations, but actually is very important, especially if you need to mention some kind of support you had, whether it's financial or technical support or moral support or any kind of family support, anything, any kind of support you had for this work, you need to acknowledge it. Anybody that helped you with discussions, interpretations, all sorts of things, but maybe they didn't do enough work to deserve a co-authorship on the paper, you need to put them in the acknowledgements. For example, if I do some experimental work and I needed some technician support to, I don't know, to calibrate an instrument or to do something for me for that particular work, I would name that technician in the acknowledgements. It will not be sufficient to co-author the technician, but it has to go a thank you for helping with the technical side and all that things, all those things. I'll put the technician in my acknowledgements. So attention, if you are writing something jointly with somebody else, but you are the lead author, and you have a disagreement, which can happen, and it happened to me. I just put it to the other co-author very simply. I said, listen, do you want to be co-author or not? I wrote this article. This is the bulk of my research. You are there because I recognize your contribution to this. But if you are not happy, I'll take your name out and I'm going to name you in the acknowledgements. It's as simple as this. When you are the lead author, you can do that if you have disagreements. You can also acknowledge family members for some reason or other. References, this is a very important section here. You must add relevant citations relevant to your paper, okay? Any statement, what do you need to cite? Anything that is not justified by your work, it must be backed by some kind of reference. And I'm not talking about, you don't need to reference well-established things like, I don't know, the Newton's law of gravity, for example. You don't need to cite Newton's papers from 1600 or classical dynamics or things that are A-level physics or university physics or things. No, anything that is relatively new and complemental to your research, and you make use of it, you need to reference it. You need to an equation that is quite new. Let's say the paper was published in 2015, and you use an equation from there or some experimental data or something. You need to reference that. Okay. It's best practice to quote articles from recent years. The closer to our present time references, the better, actually. If you can quote articles that are mostly peer-reviewed articles, it's, if possible, that's fine. But you heard my opinion about peer review and about rejecting articles and all that. It's a subjective process, very imperfect, so it shouldn't be some kind of golden rule, you know. If it's published in a preprint or something, I think it's quite good. In fact, I found some really good work in the preprints. Recently, I found a very interesting paper. So when publishing in a journal X, let's say you publish in Journal of Optics and Plasma, I don't know, what Elsevier. Try to refer and cite some papers from the same journal. And this is part of that political aspect. The journals would like to have papers cited from their own. And this is because it boosts their impact factor, it boosts their readership and all that. So remember that you go to Nature, you need to cite some Nature papers as a must, because they don't like if you don't cite any of their papers, and so on and so on. Okay, what not to do? So this is very important, what not to do, okay? Do not republish the same graph, the same text, the same equations, the same things again and again and again. If you have to, for some specific reasons, try to change something. If it's the same graph, you can go back to the plotter or whatever you use there. I use Origin, Excel, whatever you use. Change the color scheme, change the font size, change the bullet size, the lines, thickness, change something, just don't leave it the same. Because it looks unprofessional if you self-plagiarize or publish the same thing again and again. Do not copy paste text from your own published work or from other publications. You cannot believe how many times I found articles published, especially some of the Chinese authors. They copied chunks of text, half a page long chunk of text, word for word, from my own article, and they put it into their own article. Yes, they cited my work. They cited that's how I found, because I tracked my citations and I went on to read the paper. But then I recognized the text. This is my text. What the hell? They did cite my work, you know, but it's not good to copy and paste chunks like this. You can rewrite the whole thing and make it your own, saying the same thing, but make it your own. Do not republish the same data many times unless there is a reason to do so. In fact, there is a case, I'm not sure if you are familiar, it goes back to maybe 2000, 2005, around 2007, something like that. There was a guy at Bell Labs. And he was publishing amazing work in single molecule transistor. If I remember correctly, that's what he was publishing. Single molecule transistor. I mean, this is a game changer. Think about that, a molecule as a transistor. It revolutionizes everything in nanoelectronics, computing, digital technologies, quantum computing, everything. And he was publishing only science and nature papers and everything. And At some point, he was publishing a paper per week in this amazing field of research and amazing results. But there was a problem. Nobody could reproduce the data. And there was a lady at MIT who one evening was reading two of his papers, and she noticed something interesting. There were two papers published in different journals at different times on different samples and different materials, but the graphs were the same, and even the error bars on the graphs were the same. So what she did, she overlapped the papers under a strong light, and there was perfect overlap in the bloody graphs. Even the error bars were overlapped. That was a statistical improbability. It was impossible to have this unless the guy plagiarized his data. And the problem is he's not reusing a graph twice. There were different samples, different experiments, different times, different systems. He was using the same data at the wrong time. So this is, anyway, he got reported, and the long story short, he got sacked from Bell Labs. At some point, he was nominated for Nobel Prize. He got sacked from Bell Labs, and I think the Max Planck withdrew his PhD as well. So this is something that you never do. You never do this, and the problem is not fraud in scientific data per se. Is the fact that people will spend millions trying to reproduce your results. There will be people writing grants, research companies, IBM, Intel, and all these saying, "Oh, we need to do this. We can't be falling behind. We need to invest money and do single molecule transistors." And the reality is that it doesn't exist. It doesn't work. It was a fallacy. It was falsified stuff. But they spend millions trying to do it, and they waste capital, brain power, money, time, and so on and so on. That's the crime. This is the problem, the real problem. It sets back the progress. So never do this. Do not fabricate data. This is what I meant. Now, here is another thing. We don't want to fall into the other trap. When you have some results and you are not quite sure about the results, you are not sure whether your data and the results are good enough or correct even. What do you do? In that situation, my advice to you is to publish anyway. But what you do, you are very careful with the way you frame your research and your results. Do not use any strong statements. Do not say, "I discovered a single molecule transistor," or something like that. You just say, "We believe this could be. The results are not fully understood at this stage, but the data points to this." So you cover your back. You just say, "We're not quite sure about this, but these are our results. They are now in the public domain. Have a go. See whether you can find something additional, see whether you can disprove or prove," and so on and so on. You need to be careful how you frame it, how you say it. But do not leave anything unpublished. That's my advice. Always publish. Okay? Remember not to offend anybody. There will be situations when you do something and your work contradicts somebody else's work. It could be a professor that worked 30 years or 25 years or whatever in a research field, research topic, and built a career and a professional life around that, and then you come with an article that disproves everything. Well, think about that guy's life and all that research work and all the professional life and all that overnight being wiped off, somebody coming and disproving everything and making it a mockery of that. You need to make sure you don't offend anybody and you don't go you need to focus on the constructive development. This is how I put it. Sort of like almost like working together to advance the field, to improve it, and to rather than contradict somebody, because it can be very, very, very upsetting. Never argue with the reviewers. Never argue with the reviewers. Okay, you get a peer review back from X journal, and it's not positive. Sometimes can be very nasty. The peer review can be very nasty sometimes. You try to address the comments in full. Thank you, the referees, blah, blah, blah. We did this, we responded to the comments, we modified the paper. And there will be situations where you can't possibly address the comments, or they are not addressable because the referee is wrong. Okay, it's very possible. Try to explain politely why you couldn't do that, okay? But never argue, never offend them, because they will reject your paper. I want to give you a quick example here. I published an article in 2010 It was a beautiful piece of theoretical work, and I found some data from a professor at Queen Mary University of London. I found the data in the public domain. I wrote to the professor and I said, could I use your data, although I could use it from the article? It's not illegal to extract data from an article published and reuse it. If you cite the article, it's not illegal. But I said I would like to co-author you and use the data from your article to prove my theory, because I think it matches very well. And he said, yeah, sure. So I wrote an article that had a big component of a theoretical model, and then the experimental proof with data from someone else. The paper went to a journal, again, for political reasons. I'm not going to name any journal here. It was one of the IOP journals. He went to the journal for publication. He came back from the peer review. One reviewer said, this is wonderful work, publish. One said, this is total garbage. So wait a second. The guy who said it's garbage, he forgot to say what is wrong with the paper. I couldn't even address the problems because he said it's wrong. That's it. Nothing else. So what the editors did, they sent it to a third reviewer, an adjudicator, which came back with a positive comment. He said this paper is very good, publish it. And they would still not publish it. It turns out the negative report came from a very powerful person at the Royal Society or something like that. And the editors would not upset that guy by crossing him and publishing my paper. So they had an editorial board meeting and they came back to me and they said, we decided to publish your paper, providing you can do the following experiment or the following addition to the paper. They knew I can't do that. They knew. They requested something. They knew I couldn't do it. So I said, okay, guys, that's fine. I said, never mind. I said, I'm going to withdraw the paper. Thank you for your time and all that. So what did I do? I split the article in two. One experimental paper and one theoretical paper. And I submitted the two papers to two different journals. Both journals, impact factor won twice the original impact factor where it got rejected, and the other journal 3 times higher impact factor than the original journal. Both papers accepted. Okay, beautiful articles. They have hundreds of citations now. What I'm trying to say is the process is imperfect. It's subjective. It's a bit of a joke. It can be a lottery sometimes. Do not be offended if you get rejected. Do not try not to argue with the reviewers. If you can get it through, happy days. But don't take it personally. Don't be offended. Get back up, modify the paper, improve it, submit it somewhere else. They rejected Nobel Prize discoveries. Okay, that's how bad the system is. Now I have a slide on IPI specific details, IPI letters. The journal in IPI letters. What I just said is general for other journals, is applicable to everything. Specifically for IPI letters, I have some key things I need to mention here. If you prepare manuscripts using AI, you use AI help to write the manuscript. This is allowed, but the process of using AI should be seen as an augmentation of your article writing process rather than replacing the entire process. You cannot have an idea and then you prompt that idea to an AI and ask the AI to develop the model, the theory, and write the paper. It cannot be like this. And this is being picked up very easily. Somebody experienced can pick it up very easily. Okay, so the way it should be, you should have an idea, and then if you sit down the traditional way and crunch the numbers, do the equations, write things down, write the text, write everything, and maybe when you are done, or maybe when you get stuck with something, you take it to the AI to do the polishing touches, to do the augmentation, to do the other things. But the bulk of the work, the main thing should be human input should come from you. Okay. So for example, if I see articles that have too many sections, subsections, and subsections, I had articles where you had section 4, section 4.1, section 4.11. section 412, section 413, and then each 412, 413, 414 had 4111, 41112, and so on. It was like insane. It was like so many subsections, so many subsections, and so many, and most of them, they were like a paragraph or an equation or something. That's wrong. It cannot be like this. This is mostly lazy AI spitting out equations and text and stuff and bullet point lines. When you see bullet point lines and excessively being used and short paragraphs, this is not how an article should look. If graphs are generated by AI, it's also very visible. It's very visible because I can't explain. It uses very specific things, this AI. The way he labels the graphs and the way he plots the graphs and stuff is very, you can pick it up from a mile. So when you generate graphs in an article, it's best if you plot your own graphs and do them yourself rather than get graphs generated by AI. And I mean scientific graphs. The problem, so before I go to this point with this AI, I need to say something. The AI, I use AI for many things, okay? But in terms of scientific articles, is what I noticed with this AI. The problem is when you go and prompt AI with an idea, or you try to make some kind of scientific debate with an AI and enter into some kind of scientific discussion and try to construct a research article or something like that. There is an inherent bias into the AI to agree with the human. So when you prompt something and you say, "What do you think about this idea about the quantum theory doing I don't know, something to do with information and something to do with this and that and that," the first thing you will say is, "Wonderful." You say, "This is a great idea. This is potentially groundbreaking. It challenges the paradigm. It does this, it does that." You will go and praise you and encourage you into that, regardless how wrong it is. And I know because I used little tricks to intentionally prompt something that was wrong, and the AI was ecstatic about the idea and about it. I knew it was wrong. So it's not. You need to be. Don't be fooled. Don't fall into the trap of this AI, because he's biased to agree with you and keep you prompting and paying money. Having said that, the AI is very powerful, and it becomes indispensable to everything we do. There are so many things that I know, and I'm talking about peer review. I will soon move all my peer review operations in IPI letters to an AI agent, because I can't find peer reviewers. The journal is not publishing papers because I can't get people to peer review. I can't peer review myself everything, or all the topics are there. I'm not familiar. So I will have to pay like a professional kind of AI agent to run peer review, professional peer review for submissions, and then have an editorial board judgment on the peer review of the AI peer review, and do a human decision. Okay, but the initial screening will be probably some kind of AI, because I can't get reviewers to do the work, and to pay them money, it means to charge more money for articles, because I can't pay them money. From where do I pay money? I can't, and if I charge more money, then it becomes unaffordable to you guys, to all of us. Okay, so it's a catch-22 situation. So AI will become indispensable in everything we do. Okay, but in terms of scientific research, I don't think it's quite there. At least not the AIs that you have access to, and I don't think it's healthy. I don't think the quality is not there. There are problems. I'm telling you now, there are problems with this AI. Don't submit articles that discuss more than one research point. For example, I get articles on many occasions where the topic touches on cosmology, gravity, particle physics, quantum electrodynamics, quantum field theory, quantum this, quantum that, information something, all sorts of mixing up everything and everything, trying to solve all the problems in physics, from black holes to dark matter to. That is wrong, pure wrong. You have an idea, you have some model, you pick one problem at a time, small incremental steps, work on that one with a beginning, a clear discussion, a clear, legible sort of like derivations and everything. The scientific debate is there, and some conclusions at the end. And present your story as clear as possible and as simple as possible, and without mixing the entire physics and everything in sciences in one article, or trying to solve everything in one article. It doesn't work like that. Okay, so these are the typical mistakes that I get. My objective is to get as many people to publish quality articles and help everyone, because when I was 19, I had a mentor that told me how to write articles, how to publish, how to do things, and it really helped me a lot. Having that guy that was highly experienced, 500 publications all his life, he's retired now, and he just shared that the first day at that research job, the first day we sat down and he told me, sit down and I'll tell you how to publish. Because from now on you do research, you need to learn how to publish. And nobody told me before that or after ever again how to do it. Okay? And what not to do. Do not submit articles that claim to report the theory of everything, groundbreaking discoveries, grand titles and stuff like that. Keep the title simple and modest, okay? Because these grand titles, they give the impression of crackpot science, and they don't take you seriously. It's not good to do like that. I've seen too many times many equations that are just listed there, and there is no beginning and no end to it. There is no derivation. How did you get to that equation? There is no follow-up. Why did you use that equation in the text? If there is nothing that follows up from it, you don't use it into another derivation or something like that. There is no logic to it. It's just a list of equations, and sometimes, I don't know, Schrodinger equation appearing somewhere. But what do you do with that? What are you solving there? What's the potential? What are the solutions? What do you solve with that? Why did you have to write it in the first place? You don't need to write, because they look like surveys. They look like list of surveys and stuff. All these equations. When you use symbols, whether you create your own symbols, creations and stuff, always remember to define anything you do, any symbols and all the equations they have. If it's something new, you need to show a proof of derivation of that. Okay. I prefer in the manuscript rather than in an appendix. Just show it in the manuscript. If it's no proof or derivation there, we can't judge whether it's correct or not. And nobody, trust me, nobody has time to go through the derivations. Nobody. But if the derivation is there, we could look at that and judge whether it's correct or not. Okay. On the other hand, do know, and I had contributors at IPI letters that go the other way, where they show all the trivial steps into deriving something that is really trivial. Like you simplify something in a fraction or something, you write the equation again and again and again and again, all the trivial steps being shown. You don't fall in the other extreme where you show too much derivation, too much detail. So you need to show the derivations, okay, the mathematical proof, but not the trivial steps. All right. Other specific details on IPI letters. Anything that you use creatively, like whether it's images or equations or text or data sets or tables or something, and they are not your own creation, you need to reference and cite the source. You need to cite the source. Attention, if you copy an image from an article or some copyrighted material, you need permission from the copyright holder. Okay, I cannot police this. I cannot police articles and check the copyright. If somebody comes to me and says, contacts the journal and says, this article published in your journal has an image from a copyrighted something, we remove the article on the spot. We retract the article immediately because there's no other way. It's copyright infringement, okay? So it's your responsibility to check if there is copyright material, ask permission to use it, and always make sure you cite the source, okay? This is a big one, very, 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 very important. References have to be numeric, like Arabic numbers in brackets, okay? And we're not accepting anything with Harvard referencing style, okay? Where you use the surname and you list at the end in alphabetic order from the first author all the papers. That's not the style of the journal. We cannot go back and redo the referencing in the text if you submit Harvard style. It has to be the correct referencing style, please. Another big mistake is the references are not in chronological order. So I've seen introduction starts reference 1 and then reference 17. The second reference is number 17, then number 5. They are completely chaotic and random. The references, they should be in a chronological order as they appear. 1, 2, 3, 4, 5. Of course, in the middle of the text, you are like reference 30 something, but you reference 5. It can be reference 5 and 30 something, of course, but they should increase in incremental in chronological order from number 1 to the last reference as you go through the text, and they should be listed the same at the back. If they are mixed up, there is no capacity. In fact, it's a nightmare to actually try to sort this out. So you need to make sure the references, and this is a big job to actually do this, they are in the correct order and they are numeric. Citations, when you cite something, you need to put full details. That is authors, title, journal, volume, issue if there is an issue, the pages numbers if they are, and the year. And if you cite a book, you just list author, title of the book, publisher, year published, and ISBN number. If it's a website, you just list the website, okay? When you prepare an article specifically for IPI letters, the LaTeX for submission, the text file is the preferred format. Okay, so the PDF submission plus a text file, it speeds up the publication process if accepted, and is the preferred format. But of course, you can submit doc or docs files. That's fine. But if you want to do in text, learn this and do it in a text format like LaTeX. There is a template on IPI letters. You can download the template and use the template straight away. And what I recommend, and this is quite, you need to understand, this quite recent to me as well. I got into this not long ago, and I never looked back to Microsoft Word and other things. This is really powerful stuff, and you can use this for free. Overleaf.com. You go there and you create a user for free. If you are a single user, it's free of charge. You don't need to pay anything. And this is the LaTeX is it's a professional text editor. Okay. The problem with this is that you can't see what you are doing unless you compile the bloody document. So you need to compile it into a PDF and then look at it to see what you did, how it looks. The beauty of this overleaf is that it has the raw document or the source and the compiled one. They are back to back in front of you on the screen, so you can see in real time what you are doing. It's a free account. It's very easy to use. Overleaf.com. This is the website, and just remember that when you write an article, is not bullets and many sections and list of equations. It needs to be a story. It needs to be a coherent, clear story. It has a beginning and an end. Okay, and you can't explain everything in one article. Keep it simple and clear. Focus on one problem at a time. The last slide, and I'm finishing here. For IPI letters, if you do go for text files and use LaTeX to edit your articles, in terms of equations, this is quite nasty to remember the syntax for these equations and stuff. The good news, you don't need to remember any of that. I recommend lagrida.com. So this is a LaTeX equation editor. Essentially, is like a word equation editor. You just click on the image of whatever you want to insert in there, and you will put into this box, editing box, you will put the code, the text code there, which you can copy and paste it into your overleaf editing document. Your equations, you create everything in here and then copy paste it there. This is how I do it, and it's highly effective. You can find symbols for everything you can imagine, things that don't even exist in Word, and all sorts of mathematical things and really complicated things that you can't find anywhere else. You really find them here, and this is also free to use. you can use it online. The final two things, when you submit articles, I can process images from the article, but we lose some of that resolution and all that. The best is when you upload a file, please upload images as well, especially when it's accepted. The first submission, leave it as everything in one file, but if you get accepted, I prefer the images as separate files so we can get good resolution when the article is finally published. And if you have a peer review report and you are requested to do some changes or some amendments, when you respond, is good to have a list in your letter, response letter, of what you have done to the document, where and what, in response to the reviewer's comments. And this is actually the last thing I had